And let's get started with our first talk of the Saturday morning session. Let's welcome David Byrne, W2LNX, experimenting with high-speed wireless networking in the 420 megahertz band. Take it away, David.
Greetings. Glad to be here. I think this is like the 30th time I've been here, so that means I missed twice. And I can count on 2 fingers the number of times I missed the DCC. So without further ado, let me get started. So I'm David Byrne, W2LNX, and I'm actually pleased to report that I'm actually representing the Montgomery Amateur Radio Club, because this project would not have been possible without their assistance. So I wanted to do something really great. You know, it's for those who are not aware of that, it's the 100th anniversary. It's the centennial of amateur radio. President Taft, William Taft, in 1912, 100 years ago, it was actually on August 17th, signed the Radio Act of 1912. That was from the aftermath of the Titanic. So there's a little provision in there. Those people who are not commercial, that is, private individuals, have been kicked upstairs above the 200-meter band. Little did they know about HF skip and so on and so forth. So here we are. So what better way to celebrate the centennial of amateur radio than doing a really cool project? Okay. Now, like all problems, if you're looking for the solution, forget it, you'll never find it. The solution will come looking for you if you pay attention. So I wanted a project which with little development, something which I can involve my friends. And of course, this is play with a purpose, public service, emergency communications. And more importantly, we want to show this to non-hams and young hams to inspire them. After all, we live in the digital age. I gotta adjust this a little bit. Okay. So of course, I get all my inspiration at the DCC. So last year was the DATV Express, and it's a very cool project. A lot of custom-made hardware. And software, of course, to do digital television using, digital video broadcasting -S for satellite. That's what they were using. So I looked at that and I said, that's really a lot of work, and you really have to know what you're doing. Like, you know, you have to build something, you have to design this. Maybe if we just buy a fat pipe, a data link from 2 points, maybe we could do digital television for free. Okay, so I mentioned this to my friend Chris, KB3CS at the club at the beginning of the year. He said, oh yeah, go check out Doodle Labs. I said, what's that? Well, they have these Wi-Fi-like cards on 420 megahertz. Well, I've lived long enough to know that when something is too good to be true, be very skeptical. So sure enough, I did a search on Doodle Labs, and there were blogs by Steve, KB9, MWR, and a short video doing speed tests, speedtest.net. It's very nice. If you have fiber or you have Comcast, whatever, you can actually measure how fast your connection is to the internet. And he had a short 1-minute clip of that using these Doodle Lab cards 5 miles away from his house. He had a high-gain Omni UHF antenna, and then he had a mag mount whip on his car from 5 miles away, and there's trees around. And then there was the Mother Lode. It was a wonderful page of documentation by Joseph N9ZIA, and he shows exactly step-by-step with screenshots what to do, and I can follow directions. After all, I went to elementary school, so I can read. So he suggests the Ubiquiti Router Station Pro and the Ubiquiti Router Station just without the Pro. So I sent him an email, which should I get? He says, you know, get the Pro. They run cooler. The older boards run a little hotter, and that could be a concern. And these boards, apparently there's a whole industry, the wireless internet service provider industry, something which I wasn't aware of. After all, I live in a metropolitan area, I want my internet, I have a choice between 2 fat pipes, and I don't think about it. So there's this whole industry with routers and Wi-Fi 2.4 gigahertz links, microwave dishes, and you pay for your service. So I ordered the board, and since this is Wi-Fi, Well, I ordered some Wi-Fi cards. Apparently, there's something called Mini PCI. It's a small form factor. I'll have a screenshot of that. which fits into laptops or into these router boards. So this router board has 3 mini PCI slots, but no radios, nothing. So it's a pure router. The principle is that the Doodle Labs and later the Zaggle Communication Lab cards are just drop-in replacements for those boards. So while I was waiting for those boards, for those cards to be shipped from Singapore, and while I was waiting for the Canadians at Zaggle to actually start shipping, I can start learning how to use my new routers. So I ordered the Doodle Labs, and of course you need to have a pigtail. I'll show pictures of that. Something called MMCX to an end female connected pigtail. It's about 10 centimeter long. And so what are these cards? Well, this picture, this slide actually is the whole presentation. Everything that you know about Wi-Fi, actually we really should talk about 802.11. IEEE standard 802.11, everything you know about it, it directly applies to these cards. And in fact, my talk is finished. I can now leave. Okay. Well, we want to go underneath the covers. Let's see what's going on here. So from the software interface that is at the pinouts, the mini PCI pinouts, it looks like 802.11 at 2.4 gigahertz. And it uses the Qualcomm Atheros chipset. Is Phil Karn here? He's from Qualcomm. No, he's in the wrong time zone. Oh, well. He can watch it on video. And it has the RF micro devices, what I call a down transverter to 420 megahertz. In fact, if you go to the website, you'll see their card, and then they have a whole laundry list of all the different band edges that you can choose from. So there's industrial, there's government, there's military, anywhere from like 300 megahertz to like 5 gigahertz. So I'm not privy to the manufacturing, but if I were to do this, you have a generic card, and then when somebody orders it, you program the band edges of the card that they're shipping. Or maybe they may have 2 or 3 different models, because low UHF or upper VHF is not the same as microwave. So there may be several generic cards, and then they program the band edges. So I suspect what Doodle Lab is, they put up the page for the amateur radio operators, since they have the card, and let's see what bites. And these cards actually were announced last November, so it was about a year ago. And so how do you use these? Well, first of all, these are half-watt radios, and immediately I was skeptical. Half-watt? Half-watt spread over 5 megahertz? Can't possibly work. Again, I'm very skeptical. So why 5 megahertz? Well, I'm taking advantage of the ARRL sub-band plan for ATV between 420 and 426, which is the first ATV band, and 426 to 432. So there's certainly precedence to do ATV, DATV. That's just another modulation scheme for amateur television. And so I picked channel 1. I picked the first band, 422, that is the 5 megahertz band centered at 422.5. And the Doodle Labs card, you set it for channel 1. The Zaggle card, you set it for channel 2, but it gives me that center frequency. And the typical Wi-Fi configuration to use for your laptop, that is for the B&G, 802.11 B&G, you set it for 20 megahertz, and you're done. And if you're a little bit more savvy, you get into your router and you pick on an unoccupied channel, so 1 and 6 and 11. They don't overlap, and that works pretty well. But these cards have the ability to set it to a half band or a quarter band, so I need it to be within the 6 megahertz band plan. And so how do these cards work? Well, there's OFDM. I finally got a good explanation. Thank you, Phil, K9Q. What OFDM is, orthogonal frequency division multiplexing. Essentially, it's a lot of carriers in parallel, side by side, each going at a slow bit rate. And the C is the coded, which is to add a little FEC in there. So it starts out at 64 quadrature amplitude modulation for the high speed, for the higher bit rate, and it auto falls back to the lower bit rates all the way down to QPSK, also known as 4 QAM, and BPSK, 2 QAM. So hams love to look at pictures of naked radios, so here we are. So that's what it looks like. And for scale, wrong one. the green button. That's a sheet of paper, and this is the markings on a sheet of paper. So either college rule or regular rule gives you an idea of scale. So here's our Atheros chipset, which is either onboard a computer or your laptop typically, or has a mini PCI, or something called mini PCI Express, even smaller, and you just put it in there, and then they connect it to the internal antenna. So that's the Atheros, and this is your down transverter right over here, and some filtering over there, and some preamps. So this is the Doodle Labs card. I don't have a picture for the Zaga, but it's essentially the same thing. I needed to open one up so I can make that statement. So here we have the Ubiquiti Router Station Pro router board, and I inserted a Doodle Labs card there with a pigtail. So when you buy these boards, typically they come with a 48-volt power supply, and here we have the LAN ports, and this is the WAN port, and also serves as PoE, Power over Ethernet. Very useful feature if you're going to mount it someplace. And that's the other end of the pigtail. This is ham radio, so you've got to do some home brewing. So I needed a quarter wave whip, and I just needed it now. So what you do is you make one. So that's easy to do. So this is one of the pigtails I was telling you about, mounted on a large tuna can, and then an bulkhead connector, male connector. And I have one of those N male to female extension pieces, like 2 inches. So I stuck that on top with the tuna can right on top of my MFJ antenna analyzer, the UHF model, and I was able to adjust it with a pair of cutters and just trimmed it down exactly where I got a good enough SWR. So I was able to get it down to 1.2 to 1. So that actually works, and the frequencies are such that that makes a pretty good ground plane. So that was easy. Okay, so next step. So I have these boards, and I need to make them work with DDWRT. Well, DDWRT, the legacy is interesting. A long time ago, Linksys came out with their router, so they used a Linux-based router software. So the Free Software Foundation says, they sued them, says, where's the beef? So, okay, no problem, here's the code. So they released the code. And that code became the basis for the OpenWRT software, which is actually the basis for HSMM-Mesh, TM, trademark, from the Austin, Texas folks. They've done a really nice job with that for turning ordinary Linksys routers into mesh routers. And then there's this fellow in Germany, his online handle is Brainslayer, and he does a great job developing DDWRT, and then for the extra features to enable the wireless portion, you send him a couple of euros, and he's making a living, and everybody is happy, except for the poor ham who doesn't know much about networking. I'm not a network engineer. I'm a recovering software developer, and so I learned just enough to get my job done. So when you have to kind of wade through community-based wiki documentation, it takes a little bit of head scratching and patience, but you know, patience is rewarded because eventually you get it to work. Now, if you try to get two routers to be configured on a totally different frequencies to talk to each other, forget it. There's too many moving parts. So you break it down, like all good engineers, you break the things down into simple steps with measurable points of accomplishment. So the first thing, you got to reflash it, and there are rules about that. If you do it wrong, you brick it, and so you don't want to do that. So the first exercise is to configure one of my router stations as a client. So your laptop is a client to the Wi-Fi access point, your ordinary household or hotel access point that everybody uses, is familiar with, and doesn't even think about. So I configured one of my routers to be a client. Okay, so that's done using the Winstrom 2.4 gigahertz Wi-Fi card. Second exercise, I configured another router to be an access point. So I know I would get that to work. If I got that to work, I'd connect to it with my laptop. I needed to have a separate SSID. I didn't want to confuse it with the one in the house. So I used BORNet. So what's BORNet? Broadband over amateur radio network. And I asked an artist friend of mine to draw me a nice boar. After all, project needs a good mascot, but I'm still waiting for my boar. Anyway, here we have it. So, okay, and then the third exercise took literally a couple of mouse clicks, and I was connected. So my first router was connected to my second router, and I was up and running. Okay. So what does it look like? Well, this is the DDWRT web page for the web server inside the DDWRT running in the router. And let me tell you, just let me remind you, it's running Linux. And it looks very similar to the Linksys router page if you were to just go to Micro Center, or no longer CompUSA, but anyway, you get a router and that's what it looks like, not surprisingly. So what you see here is that the channel is set to quarter wave. Oh, 2. Okay, so this must have been the Zaggle card, because channel 2 is Zaggle. When you buy these cards, they tell you what the offset. Zaggle publishes right on the web page. This is the offset to 420 megahertz, done. With Doodle Labs, when you buy it, they measure the cards, they give you the performance numbers, and then they give you what the offset is. So apparently that's part of they don't disclose that until you buy it. And, oops, well, it doesn't matter. And I set the antenna, the TX power. You type in 18, what you really mean is 28 dBm. So apparently, in the Wi-Fi standard, there's this maximum power that you can set, so they add a 10 dBm offset. Now let me go to the previous page. So here, as I had mentioned before, I could tell that this is the access point because I set the frequency, and then the client, next, I'll learn how to use this. The client, you don't set the frequency. Like all good clients, Wi-Fi clients, they search for an access point, and then they give you a choice. So this is the access point. Again, we set the power. And what I wanted to do, I wanted to have easy access to the web GUI page. So I enabled remote web GUI access over here on port 8080. And now the new routers, they turn on all the security features. In the old days, all the security features were turned off. So the first thing you had to do is disable that, because you don't want nefarious people to connect to your router or over your cable modem and just mess you up. You don't want that to happen. But for ham radio applications, I wanted to do that. So that's what this shows. So this is my simple configuration. So I have my access point, and I set the WAN address, the wide area network address, the so-called internet and LAN, local area network address. But you know, everything gets bonded together, because one of the features of that setting that GUI, it takes all the Ethernet ports and the wireless LAN Ethernet address space and kind of merges them together. That is, all these address spaces are available at any port. Very, very nice. And you'll see why that's actually useful when in a later shot. And I have a netbook. This is the address of that. And I deliberately wanted to do this project with everything was very generic, commonly available, and I wanted to use a Windows netbook. I know this is a Linux crowd or Mac crowd, you know, heavy duty, but this is a project for ordinary hams where they can go shopping, just follow some directions, and they can put together a high-speed link. So quite deliberately, I'm running Windows 7 on the netbooks, but like all good laptops, they will boot Linux when you plug in an external USB hard disk. So that's what I have here. And over here, the client, notice the wireless wide area network address is just the client address. Typically, the router is set to some .1 address. Typically, it doesn't have to be. And this is my netbook address for that. And here's a summary of all the addresses, and you can look at that at your time, but I have that for completeness. So what applications did I use? Well, first of all, to use ham radio precedents that had to be video. So I can sneak this in under the guise of DATV, so nobody can hassle me about, ooh, you're going faster than 56 kilobaud. What's a baud? Is it 1 bit per second, 2 bits per second, 4 bits per second? Interesting question. So I discovered this webcam software, YoCam, from the March QST about how to use an ordinary Logitech web camera as a microscope for SMT. So I bought that. I said, oh, by the way, I can always have an extra webcam. Why not? To my surprise and delight, it has a built-in streaming web server. Just click, turn it on, and start streaming. They tell you what the IP address is and what the port number. Great. And the other thing I needed is to get some real benchmarks, to do file downloads. So there's a free piece of software called HFS, HTTP File Server. So on the Firefox download page, you can get a number of bytes per second, which is quite handy. So across, well, I wouldn't say across the room, I discovered if they're too close, 3 feet apart, they really don't perform very well. But you gotta have at least 20 feet apart. I think it has to do with ACK timing. So this is the first, I like to do things in alphabetical order. So the Doodle Labs card, this is, what were we doing? We're doing a file download, so we're getting 5 megabits per second. And this is the Zaggle. So, wow, really worked. And let me tell you, the first time I did that, it was a thrill, because I grew up from the 1200 packet radio days. I wish Phil was here. I'd credit him for his NOS. That is a network operating system, TCP/IP on a PC over the 1200 bits per second modem, and then later on we're experimenting with the Dale Hetherington 56 KB modems. It's a shame those never went anywhere. The nice modems, serial in, a 10-meter IF out, put it into a transverter, and you're done. So, does it work in the field? Does it work? Of course it works in my house or it works in a demo room. So I set a modest acceptance criterion, 1 megabit per second at 10 miles. What is that, 16 kilometers? Something like that. So Google Earth, I was able to identify some spots. But what clued me in where to do some range testing was right in my backyard in Virginia, Shenandoah National Park, Shenandoah Valley. And this article in July 2005 tells the story of Jason and 4DSL, where he and his buddies are running around the valley doing range testing with 2.4 gigahertz. So I contacted him. This is what I wanted to do. And he said, really cool. And he was very helpful because he helped me save time, that is, stay out of trouble. Don't go to places which he knows won't work. Go to places that do work because he's tried them. So basically I followed the article and that's what I did. So first I wanted to do 10 miles. So as I said, using Google Earth you can spot. So Skyland Lodge is about, it's about over 3,000 feet, and then across the valley, halfway through the valley, there's an interesting geologic formation, and it's the Massanutten mountain range, short mountain range, about 1,800 feet. And then further beyond is the end of the valley, which is the Allegheny Mountains. Those are much taller mountains. So, and there was the Route 211 that crosses over the mountain, so there's a place, you know, get off the road and set up another station. So this is the Google Earth elevation, and this is absolutely terrific. And you can save it as a JPEG. There's a save mode. So no obstructions. I think you can see, yes, you can see the red line here. When it's printed, you don't see it. So this is my antenna setup. This is an M squared. This is the short 5-foot antenna, 11 elements. And notice the radio is mounted there. It's a Container Store special. It's a cookie box, a $7 cookie box, probably cost them 50 cents, if that much. And this is a piece of LMR. And this is my digital coax. I claim that the coax cable of the 21st century will probably either be Cat5 or Cat6. That remains to be seen. So I have access to my LAN port, my WAN port, but most importantly, I can feed it power through the PoE, Power over Ethernet device. And here it is. So this is my power supply for the field, and this is my 18 ampere hour battery. I learned very quickly, you put the battery in the middle, because so so it's balanced, so you can pick it up. I love these Craftsman cases. It's plastic. It's non-conductive. And this is my PoE, Power over Ethernet. This is the orange cable, is the long cable, and that goes to the radio. And this goes, of course, to the laptop or anything else that talks Ethernet. And 48 volts. Where on earth am I going to get 48 volts? You know, I'm a 12-volt kind of guy. I'm a whole station, everything is 12 volts. And 120 volts AC is just a way of getting 12 volts as far as I'm concerned, to charge up your batteries. So I don't want to fuss with two kinds of batteries or a battery. Forget it. You make 48 volts. It is much cheaper to spend $15 on a 75-watt power inverter, 12 volts to 120 volts, so you can power that. See, it's plugged in. And, oh, a bonus is I can power my laptop and run the screen at full brightness. You know, these netbooks, it says 3-4 hour battery, forget it. Divide, subtract 6 dB, I mean, it's divide by 4. If it's a 4-hour battery, it's a 1-hour battery. Plan, you know, that's a very good metric, a third to a quarter for planning purposes. So there's my station, and I actually left this on once and ran a whole day, and it kind of ran down to 11.5 volts, no problem. The router board draws about 5 watts altogether. So here we have Vic, WB2U, and Alex, W3JG. There's Alex over there. Okay. It seemed very hard at work at the station. And so this is the setup. This is the station. And I did the vertical polarization the first time I did this. A painter's pole. This is a 24-foot painter's pole. But I realized, oh, all these pipes inside, it makes it pretty stiff. And this is a patio base, 29 pounds patio base. And I did all the work at the other station. I don't have a picture of the station. Let me go back. Because I was able to remotely connect to the web server of the access point of the remote station. Because the LAN port and the WAN ports were bonded together because I turned on that GUI button. Remote access, remember that? That was a very useful feature. So basically their job was to answer questions. This is on the patio of Skyline Lodge, and boy, we had a lot of questions. People came up. So I actually had their plastic plaque with the cover article of the QST article. And in fact, the manager comes out, frown on him, and says, "What are you guys doing?" He says, so I was ready for him. Say, "Hey, look, this is what we're doing, and this is we're practicing for emergency communications." He says, "Oh yeah, tell me more." So he went from like challenging to like, "Wow, this is really cool. Tell me more." so I was ready for him. So this is a screenshot from YoCam, and with their permission, I use this picture. This is Vic. The FM radio was the audio portion of the video, plus for coordination. And there's Alex over there. So these are the results. We did this twice. So Skyland is over 3,600 feet, Massanutten Mountain. I didn't go all the way to the top, so I stayed at the 1,500 foot. And with the Zaggle cards, we're getting 2.5 megabits per second, and our download is roughly 300 kilobytes per second. Not bad. Not bad at all. Wow, this stuff actually works. I'm starting to become a believer. And we did it again. We wanted to do it with the Doodle Labs cards, but it turns out there's a little park, a public area where you can get off the road and set up there. One of the things we learned from that exercise was compass bearings do matter. The magnetic declination matters. We were scratching our heads. This is William, W3QX. I said, why are we 20 degrees off? Why is it pointed that way? We couldn't understand. Magnetic declination. 10 degrees. So I actually went out and bought a nicer compass where you can set the declination. So the magnetic north and the true north are separated. So when you find your magnetic north, you actually have your true north. And then you can look it up, what the declination is. At 10 miles, maybe it doesn't matter that much, but at 50 miles, it does matter. 10 degrees at 50 miles, what is it, the tangent of that? It's like 10 miles. Woo. That matters, so you really want to aim at each other. Similar numbers for Doodle. That's a little faster, 4.5 megabits per second. Now we're ready for the big test. I really wanted to get this big test, and I was running out of time. It was getting to be September, and it's hurricane season. Oh, 10 minutes, thank you. And 57 miles, 92 kilometers. And this is our setup. This is the painter's pole is inside a 2-inch outside diameter PVC pole. It really stiffened it up. And I wanted to get the extra gain, the same gain as the 20-foot, the long M-squared antennas. So I have 2 of those antennas. But more importantly, a stacked array like that, yes, you have the horizontal azimuth because it's an 11-element beam, but it compresses the vertical azimuth, the vertical beam width, narrower, because you really don't need to light up the sky or listen to the sky. It's simply not useful. So here we have Eugene KB3 TZH at Hogback Mountain Overlook, and he's actually a brave fellow, very dedicated ham. He's on the other side of the barrier, and then there is, well, it looks like a very sheer drop-off, but it's actually more of a gentle slope, but you really don't want to lose your footing and fall overboard, so he's quite dedicated. And there I am at the other end. This is Reddish Knob. We needed a day where it was a blue sky kind of day. And so I was looking at the Doppler radar websites, and William was looking, he found these websites for lightning strikes. He said, oh, today's a good day. There's a band of lightning across near the Canadian border and going through the Gulf of Mexico, across the Florida Panhandle. No lightning around for many miles. Good, we're going. Because up here, this is a small parking lot. There used to be a ranger station up there, and this is the highest point around for like a radius of 50 miles. If there's lightning in the area, if there's a thunderstorm, you will get struck. And I kept reminding myself, this is a hobby. This is an entertainment, a recreation. You don't endanger your life and your friends unnecessarily. So what you do is you get your information, and then we agreed with a scheme that if this, in the mountains, the thunderclouds appear, we just scram. We forget it. We bug out. We just pull the plug on the whole operation. So there is the Eugene at the other end, 57 miles away. And here's the best part, the numbers. So Hogback is roughly 3,400 feet, a Reddish Knob 4,400 feet, and we used the radio, the Zagel radio, and we ran out of time to do the Doodle Lab. We just swap out the radios and screw the end connector and unplug the Cat5, but we were running out of time and it was getting late, so too bad. But it's an opportunity to go back. So we got a really good signal quality, but we couldn't make a connection. So Chris, KB3CS, and I looked at each other and we said, act timing. So at least we had an idea what the problem could be. So once we started playing with that, and then on the DDWRT page it says default 2,000 for 200 for 2,000 meters. I said, So what does that mean? Well, 190 is close to 100 kilometers. Let's do that. So first we tried it with 50,000. Started to work. We did 100,000. Maybe we could make it work better. Well, is it 100 kilometers or 200 kilometers? Because, it's round trip. This is a TCP connection. This is web, HTTP. So for every packet, you got to get an acknowledgement. So we were playing 100,000, 200,000, 400,000. And in the documentation, it says you can set 0 for auto detect, but the problem with that is that's for debugging purposes, but each time you establish a connection, it's got it's a couple of seconds for it to settle down, detect, so I don't know exactly what the answer is. So our bandwidth was actually choppy. But we managed to get 50 kilobytes per second to do a quick download, but it makes you appreciate how really slow the speed of light is. For acknowledging every packet 200 kilometers, you do the math, that's roughly 700 microseconds, nearly a millisecond. So I'm actually impressed with these numbers. So I suppose each packet has more than one byte in it. So this is what it looks like. And I needed to make sure what the time scale is. So the horizontal axis, a full axis is 122nd. And I need to understand this further, why I get numbers like this. One thing I'm 99.9% certain I did this at the same time I was doing a download, because YoCam, it sends a frame, a full video frame, and then sends another one, and it's a little jerky that way. But a file download, that's continuous, so I need to get an explanation for this. So, conclusions and recommendations. This stuff works. Holy mackerel. And in retrospect, this is actually very easy. I had to go shopping, and the M2 folks were very helpful. There's Jason Boyer there. His job is to sit at the desk and answer questions. And you know what? If you need equipment and you need advice, you're happy to pay $100 for a piece of LMR cable. So the cable costs $10 and $90 for his free advice, or $90. It's great. So that's how I was able to do. So I ordered 2 sets of these antennas, 2 pairs. Anyway, so 10 to 20 miles seems to be a practical limit. You can get some really megabit per second bandwidth. It seems the Doodle Labs are faster than the Zaggle, but the Zaggle is cheaper and more available in this country. I have to fill out the FCC Form 704 swearing that I won't sell these things. So I suppose I could give them away. Basically interference, they wouldn't know that. So I signed it, David Byrne, comma, W2LNX. That's part of my, that's my last name actually, W2LNX. And mostly COTS. The Ubiquiti Router Station Pro has been discontinued, but they're floating around on eBay. Occasionally they appear at this, I forget the name, but in California there's a big website, they sell equipment, and occasionally it shows up there, and they'll send you an email saying it's back in stock. But also if you go to the DDWRT database, you go search for routers that they support, you correlate that with those that have the mini PCI slots. So I'll talk about that in the next couple of slides. So it needs line of sight. I actually tried this, and we did for a parade at the Tacoma Park, Maryland. So I ran with 2 arrow antennas down an avenue full of trees. It's like, I think it was about 1.5 miles. So we got a 10% signal quality, and we downgraded to 1 megabit per second. So it worked. But with microwaves, 2.4 gigahertz, forget it. 1 leaf is opaque. A human body, well, that absorbs microwaves. That's even worse. So 420 megahertz is more forgiving than 2.4 gigahertz, but you really do need line of sight. Yeah. So So we need to basically we need to continue experimenting. We're going to establish a network of 3 routers and see what we could do with that. What I'd like to do is connect local area networks, wireless local area networks running on 2.4 gigahertz, could be HSM and mesh, or just a conventional access point. I need to find another video program that runs UDP instead of TCP, so I could just stream. So at least I get double the throughput. And these are some of the boards that I found. I actually have them. I need to start playing with them. This is in production. Gatesworks, Avila board, and the PC Engine's in production. You can buy them. And best of all, for cheap, $80, a Intel Atom motherboard with PCI slots, and you can just, for a couple of dollars, get a mini PCI to PCI adapter. And then you can run regular Linux with the MAD Wi-Fi drivers on my to-do list. But the most important point of this exercise is to do this, improve county public safety communications. And this is last year, around this time. These 2 folks at the NIH and the National Library of Medicine wrote an article how to provide some assistance using WinLink 2000, whatever it is. So I invited them to come to the presentation. I rehearsed this on Wednesday night at my club. And so Victor was there. He's all excited. So I said, hey, there's another tool for emergency and public service communications. So, these are the folks from the Montgomery Amateur Radio Club who helped out. There's Alex and Chris and Eugene, Vic and William, and I had mentioned Jason, and many others, including my wife, Abby, and 3WKO had to put up with my obsession for the last 9 months. So I promised I'm not going to talk about this starting on Monday. Now, do I have 30 seconds? 15. So this is a personal acknowledgement. A nice man in 1964 gave me this book, and it's changed my life. So while I have 10 seconds left here at the podium, give a child a book. You never know whose life you might change for the better. Thank you.